buildings. So the virtual stage is yours.
Yeah, thank you very much for the nice introduction. Yeah, welcome to the presentation on the radio-based transmission protocols. I have to explain before I start why we did it. We do consult, or we also do implement smart buildings very often, and very often you're also confronted with many different radio-based protocols, and the question is always on the table: which one do we take? Shall we take the same as we used last time? Shall we take a different one? And therefore, very often we were confronted with the questions which radio protocol to look at. When I looked at the market for comparisons or studies, I didn't find a comprehensive one, and therefore easily said that's why we spend some time on doing it, well, first of all, for ourselves. And since the result, I think, is quite interesting, I'm happy to present also the result here during this conference. First of all, before we go into the details, there's a web page on which you can find also the slides or the handout from my presentation. The link is displayed here, but it's also copied in the chat window, so you can easily click on it and you end up with this web page. You also find some white papers which I present more roughly in the remaining 17 minutes, and a few other information as well. But most important, the presentation is available on the web page. Here are some protocols, or basically the ones we looked at for our comparison. You see many different protocols, and basically what I said before, the question comes up: which one should we consider in the near future, but also in the long run, and not to overlook any important protocol, maybe which may be rising in dominance within the next few years. However, before we go into the comparison, the initial question on the table is: why do we use radio-based protocols at all? Because as most of you, most likely everybody knows, there are cable-based ones, and why should we use radio-based protocols at all? And if we say radio-based protocols do have some advantages, the next question is: how do I compare them? So we tackle those two issues. We start with the system architecture of smart buildings. Usually it's a 3-layer architecture, starting with the field level where the devices are in, the automation level where the basically network and the controllers are in, and the management level basically where you find the services. And in traditional setups, you have the controllers, and they are the one to decide whether light is being switched on and off, or shutters are being pulled up, or they have to rise or to lower shutters, for example. And the trend in the market is that some of the intelligence, not all of it, but some of it, is being deferred to the management level, namely the building management systems. That's not a classical SCADA system, or in Germany it's called GLT, Gebäudeleittechnik. BMS systems, building management systems, are much more versatile and powerful in comparison to the traditional SCADA systems. But this trend is increasing. Also not valid maybe for every building. There are also buildings with traditional architectures, but we deal with many very innovative projects, and this trend is very clear on the table. So, and once you have also a very intelligent building management system, you can hook up directly smart devices, so not everything has to go through controllers. Controllers will remain their importance, so my story is not that those controllers will completely disappear. They also will have a saying in some logic within the building, but some logic, especially the more intelligent ones and holistic services, do migrate and are being deferred to the building management system. What's behind this? With a building management system, you can do much more which is usually being done in traditional room automation or facility automation scenarios. I won't go through everything, but there are some extracts of features, we call it value add services, which you can do once you have a very sophisticated BMS, or the other way around, if you have a BMS, what can you do more in comparison to traditional room automation and facility automation? And if we go briefly through the highlight, you can book meeting rooms dynamically with your smartphone. This you can do also without a smart building, but with a smart building, a building knows which room is free, which room has which air quality. You can condition a room. You can do previews of how the room situation might look like in a few hours, because a building management system knows how many people are in the building and so on. So you can do smart booking of conference rooms and very important workplaces as well, much more in detail with a building management system like this. You can do moving trails. You can watch the occupancy of meeting rooms or resources, and you can provide heat maps and moving trails. You can manage your workspace much more efficiently. You can also allocate workspace for employees and therefore save energy costs, for example. You can do indoor navigation and so on. I don't go through the rest, but as I said, there are many features you can do, value add service you can do with a true building management system. This basically is an extract of another study, which we shortly release. You can also find a link on the webpage you presented in the beginning. And therefore, it's a very comprehensive study on the future of room automation and smart buildings. So what I'm trying to say here, a true smart building offers many benefits. In order for a smart building to operate professionally, it needs much more data, and therefore it needs much more sensors. And therefore, that's basically one reason for radio-based protocols. Smart buildings require more data, and more data means more sensors. And if you talk about more sensors, you have to hook up many more sensors in rooms, in areas where you can't lay a cable to. And therefore, radio frequency-based sensors also offer very higher flexibility, especially in retrofit scenarios, but also, of course, in new buildings. Even for new buildings, which we currently consult and support, there's always a large extent of radio-based sensors, because you can't cope with it if you want to lay cables to every point of interest. Now comes the next case. The next step, if we know there are certain additional value add services, we have to look first of all at the classical room automation. We can look at the use case facility automation, and we can look at use cases for value add services. You can't read the slides here in detail, and unfortunately we don't have the time to go through everything, but that's what you find in the study, which is available on the webpage, which I presented in the beginning. And again, for those coming in a little bit later, there's a link in the chat window. But what we tried here, that first of all, we tried to summarize and get a grip on what exact use cases for those various areas are really on the table. What demand do I have to satisfy when I talk about additional sensors? Once we looked at those use cases, you can further develop it into what kind of components do I need. And what I'm trying to say here, that was very important to us. Before we come into the comparison of the RF-based transmission protocols, I have to wonder, what do I want to achieve with them? What use case do I have to apply? Because only if you know what you want to do, you can decide how it's being done best. And that's what I'm trying to say here. One slide back, to get a grip on the exact use case to be implemented. And from this use case, you can say, what kind of sensors do I need? And once I have those sensors, we can look at the data which needs to be transmitted, and we can summarize, and that was very important for the start of the comparison, what kind of data volume needs to be transmitted. And usually it's low. It's 1 to 10 bytes. So please keep that in mind when we later compare the protocols. Any protocol which is very powerful and which can really transmit lots and lots of data in a very short time, might not be suited for the sensors we need for what we understand as a smart building. Saying that very powerful protocols are not bad. On the contrary, they are very important for other applications, but not for the applications we need to do in a smart building. That's what I'm trying to say. Therefore, the data volume, before we do the comparison, is low. So I don't need a protocol capable of sending 100 or 1000 byte or even megabytes. The transmission frequency rate is very low. Very often, those sensors transmit data once per hour, or even if they're faster, it's never the case that it needs to be faster than 10 times per second. So therefore, the amount of the frequency rate is very low, or the number of data telegrams to be sent. And the time criticality usually is in the middle range. So it's sufficient if a data telegram is being transmitted within longer than 60 seconds. Some sensors like push buttons, for example, are more time critical, but even then it has time, let me say, up to a tenth of a second. It doesn't need to be faster than a tenth of a second. So summarizing here as a basis for the comparison, it's low data volume with a medium, low to high, depends on the sensor, low to high frequency rate, and usually low or middle time criticality. And if it's high, it's, as I said, sufficient if it's faster than a tenth of a second. So those are the requirements we see are on the table for a protocol which I need for a smart building. If you do this, you can develop also some other criteria. You can first of all come to the suitability of a frequency band. And we decided this will be a knockout criterion, because if the frequency band is not suited, then the rest is of no use to do comparison. And it's really suited high, and therefore gets 2 points if you have low data rates, low data packets, and the range is also short, because usually you have a certain infrastructure within buildings, and with many sensors, it's better to catch a certain number of sensors within one area and not to have an area which is too large. Otherwise, it results into too much interference, collisions maybe, but also you get too many sensors to catch within one gateway, for example. However, we decided also there need to be other criteria, like, for example, manufacturer dependence. In order to save a little bit time, I just go to a highest level. The best is if it's the best is here. It's the low manufacturer dependence. It's a standardized protocol. Components are available from numerous suppliers, and also the interoperability is guaranteed. So this is, of course, the highest level, and the others, I think, are self-explanatory. The other thing is regarding the infrastructure. Best would be to have no own infrastructure, even though it's a little bit of contrast to what I said before. If you have no own infrastructure, then of course it's being provided by somebody else. If you have to do it on your own, which unfortunately most cases you do, at least it's a lower classification to be considered later on. Very important from our point of view. It's also whether it's possible to integrate the sensors into a smart building. Let me go to the highest level. Our protocols get 2 points if they're multiple controller suppliers, meaning they are suppliers from controllers which offer interfaces or gateways. If this is not the case, of course, the integration of the sensors into smart buildings is handicapped, and therefore gets a lower classification. We have another criterion which is called availability of components. Also very important from our point of view. I look at the comparison from the point of view of a systems integrator who needs to smartify a building in the very near future. So if technologies are available in laboratories, very nice and fine, but I need something which I can order from a manufacturer's or supplier's catalog. And therefore the highest level is if the components are really available. If they're not available, they get less points in our comparison because they're of no use for us. So next one is very important. That's possible to measure and test sensors. So test devices and documentation of test devices needs to be available. Next one is the power supply. The best is, of course, is a self-powered battery is one step less. If it needs an external power supply, of course, that's the worst scenario. Lastly, it's a data encryption. Of course, there needs to be a high data encryption offering high security. With low data encryption, of course, less points. So far so good. These were the criteria which we defined. We didn't, let me go one step back. We didn't define weighing factors, which might have been nice, but it's always difficult to decide which criteria is more important than the other. So we treated everything equally. With this, we developed so-called profiles for every protocol. The protocols I said before. And for every criterion, we, of course, associated to certain points. There's unfortunately no time left to go into detail, but again, the whole study and the white paper is available from the webpage, which I presented in the beginning. And in the end, we came up with a summary table. And basically, that's one which brings me nearly to the end. You can see here the names of the protocols which I showed before. You here see the classification, which I said before. You see also that from the frequency band, also long-range protocols like 5G, LoRa VCTN, narrowband IoT, and Sigfox, but also wireless LAN is much too powerful. Those are very nice protocols and powerful protocols and suited for many other applications, but for the kind of applications and use cases we have in mind, and for the sensors we need for our use cases, we think it's much too powerful, consumes too much energy. The long range is also a handicap, and therefore those radio protocols with a low mark here, and we decided this is a knockout criterion, unfortunately also end up with a low overall suitability. The other protocols, we had a closer look. I don't go into details because of lacking time, 2 minutes left, I think. But you can see here basically the bottom line we came up with. So that's basically so far from our proceeding. And if we now come to the second question, how do I compare? We strongly believe a comparison can only be done if you, in the first step, define what do you want to do with it. Same if you go to a car dealer and you buy a new car. You can't go just to any car dealer and just buy any car. You better wonder whether you want to go with your family, with some kids and do outings in the mountains, or whether you rather are alone and you want to do a sportive drive along a coastline, or if you want to transport many, many things. So coming back here, if you don't define the use cases and if you don't transfer them into decision criteria, comparison is of no usage. You always have to decide what your overall target is. And therefore we did the two-step approach. Yes, we looked at the frequency band before, and only if this is suited, then we had a closer look at the different protocols. So far so good. 30 seconds left over, halfway in time. Here are my contact details, but again, remember the webpage for the handout and for the links, again, which you can find in the chat window, and they see everything for download, for further use. And if you have any questions, we either see each other later, or you can send me emails or call me. You can see even my cellular phone number here. I hope that was informative, and hope to see you somewhere later. Thank you.
Thank you, Michael, for your good comparison, for your proposal how to compare these technologies.